It is a collaboration between scientists and those of us who are curious, concerned, and motivated to make a difference. It is how people can make an impact on issues they care about and help science. So basically, it's just a mutual understanding and collaboration between scientists and those who are passionate about science. So, what are the basic steps, or what is citizen science in real? So, as you can see, there is an image there. Uh, Imagine this is a tree in your neighborhood. So, approach this as a citizen scientist and say, what do you notice? Uh, I mean, there are multiple questions you could ask yourself being a science student. Uh, like, how many leaves do you see in the image in relation to the flowers? And are there any buds on those branches? And are the flowers in full bloom or are wilted? Like, what is the situation there? We have to make observations and make those observations reported. So, like, can anyone say how many leaves do you see in there with relation to the flowers? You can give your reply in the chat also, no issues. Is there any flowers? I mean, is there any buds you can see? Yes. Yes. There are almost no leaves if you closely watch. I'll try to zoom if possible the image. Okay, see, there is basically no leaves there, only some flowers, some pink flowers, and buds. You can't see any buds. All the flowers are bloomed, and it looks nice. So, what are your observations from that? Like, how can we answer this stuff? That's basically what citizen science is about. I mean, in terms of, in a simpler term, when it comes to other fields, I mean, this is biology. When it comes to physics, when it comes to astronomy, there are other things, but basically it is the same. You have to make observations, you have to analyze the data given those steps. So, what you did is that you just participated in citizen science. You just shared your observations that scientists can really use to research. Maybe they can research for climate change or for the appearance of destructive invasive species and make references and make their decisions based on that. It's basically that. It's just that simple. So, what skills do one needs to have to do citizen science? Let's look into those skills. Anyone doing any science is basically using science process skills. Okay. So when we are doing citizen science also, we are using science process skills. Um, Science process skills include basic skills like asking questions, observation, collecting data, reporting the data, analyzing the data, and communicating the results. But what we did in just the previous experiment or the citizen science project, like thinking about what is there in the plant, is, I mean, we did not use all the process skills. We only used specific process skills. What are those process skills? They are like asking questions, observing the tree, the plant, how many leaves are there, how many buds are there. Then we collected the data by observation. Then we report the data. Then it's up to others the scientists who are learned about the, who are more knowledgeable about this stuff to analyze the data and to communicate the results. Similarly, there are other projects where they will give us the data where we have to analyze it using some softwares, or we have to make our own observations and report the data. Like, it all varies depending upon the type of the project. So that the question comes, who can do citizen science? Is it limited to a certain section of the society? Is it limited to the students, the college students, or even can an old man do that? Those questions arises. So let's see. Okay, so citizen scientists are typically people without specialized training. So you don't need any special training. You just need the curiosity and passion for this. Then who can participate in scientific research to help answer questions that cannot be answered without their help. So without their help, in the sense, see, if a scientist needs a set of data, and they are in a place where they are like restricted by their like ability to get big data. So if almost all the citizens around the globe contribute in their own ways, like give a small observation to this scientist, then they will have a large amount of data which they can analyze and get information. So citizen science is basically helping with big data. I mean, like, big data in the sense they can take a huge amount of data by individually contributing a small amount of data, or the scientists they give out data. Like for example, there are telescopes which generate more than 15 TB of data per night of observation. So a group of scientists or scientists alone cannot analyze and make results from those much amount of data. It takes lot of time, so they distribute it to people. Then the people analyze it, observe it, and they make their own conclusions and help the scientist with that. It's basically a division of labor, and with that, large works are done in a short span of time. So the answer is anyone can do that. Anyone can do citizen science. Even retired people can do, even busy working adults, even if you are a busy person who is busy with their job, like daily 15 minutes can be used for this. Even youth groups, even from a high school student to an old person, they can do this. And even community groups can do this. It's that simple. So if possible, I'll try to show a video about citizen science. And like in this screen, you can see a robot holding a bird. It is the logo of Sky Startup, which is basically a website where they give out lots of citizen science projects. They organize it. Then we can register it. We can take a course on citizen science. Then they will tell us like if we are qualified. I mean, qualified in the sense like basic understanding we have to have. If we are I mean interested to do it, then they will show a list of citizen science projects uh, which we can take upon and do. And they will give badges. They will give like each citizen science program has its own benefits. Some will give you satisfaction, just satisfaction. Some will give you certificates. Some will give you like even you can get named for discovering something. There are many options for that. Okay, wait. I guess my screen is not visible now.
Yes, you're not sharing the screen, right?
Yeah, once again, I'm trying to. Okay, what I was trying is that I was trying to share a video, but the system seems a bit unresponsive. So let me try once again. Please wait one more minute. I'm trying to like rejoin the meeting and trying to present once again.
Okay, Anna.
Sorry, there seems to be an issue with the system. I'll try to present it from with the help of some friends. Please hold on for a few minutes. Okay, so let's continue the presentation. Uh, okay, so actually this video is tells a brief idea about what is citizen science, how it can be done, and what are the types of people doing it, and how are they doing it, those stuff. But since there is some kind of technical issues, we won't be able to see it now. So let's move on with the presentation. Next slide, please. Okay, so why is citizen science important? We can look those aspects. So, because of citizen scientists, we now know that there are a 50% decline in the population of birds, and they are breeding earlier. It might be an indication of global warming or climate change. And though it's funny, it's true that citizen scientists, because of citizen scientists, we now know that there are 50 plus types of bacteria living in your belly button. Then there is also a discovery that first flowering of 19 species of plants have moved 9 days earlier over the past decade, which might be an indication of climate change. And there is also a finding that invasive mosquito species have arrived in Germany. So these kind of steps, like it's more what I'm speaking is of more related to biology, but there are citizen science programs that are related to physics, chemistry. I mean, almost all parts of science. Let's see some aspects of citizen science. I mean, some achievements of citizen science from the field of astronomy. Next slide. Okay. So because of citizen scientists, now we know that there is a different kind of aurora in the night sky. It actually happened in Sweden, I guess. So there are a group of people who are watching sky, amateur astronomers. They are watching the sky, and they saw a strange kind of light in the sky. Usually there are auroras that are aurora borealis, aurora aurealis. I mean, usually there are certain kind of auroras. They don't look like this. For those people who don't know what is an aurora, it's basically the Earth's magnetic field reacting to the charged particle from the sun. So, because of Citizen Science Project, they were able to identify a new kind of aurora in the night sky, and the citizen scientist itself named it, and they named it Steve. So why it might be important? Because like by understanding more about auroras, we can understand more about Earth's magnetic field, its relation or reaction towards the sun's charged particles, and who knows what if something happens. There is always a threat from the sun that it will release a solar flare, which will fry all the electric circuits and all the equipments on the Earth. So if we were to understand more about all this stuff, we might be able to prevent such a calamity. So that's the aspect of that, and we can see another one. Next slide, please. Okay, because of citizen science, we now know that there is a Jupiter-sized planet far away in some other system. This planet was discovered by a citizen science program called TESS, Planet Hunters. Basically, what it does is that take the data from the TESS satellite, Transit Exoplanet Survey satellite, and they use that data to see the light curves of the stars. And if there is a dip or dim in that light curve, that means that something is blocking the path of the light from that star. So they were analyzing like that, and they discovered there is a Jupiter-sized planet which is supposed to look similar to Jupiter around a planet, around a star that is much more longer than the nearest planet system to us. Let's see another one. Next slide. And it is because of Citizen Science Project now we know that there is a special phenomena called Hani's Woolworth. It's basically the leftover gas after interaction with a nearby passing galaxy being ignited by the emission of light and rays from the center of the spiral galaxy that is above it. So there you can see a green color substance, some subject. This is discovered by a school teacher from Dutch origin, and she named it Woolworth. Woolworth in Dutch means an object. She was there is a project called Zoo, Galaxy Zoo, and she was analyzing the images, and she found this weird looking object, and she reported it to the scientists. They analyzed it, they did more data collection on it, and they did more analysis on this, and they found that it's a new kind of phenomena, and they named it on her name, that is Hani, and she got to name it Hani's Woolworth. So these kind of things happen. Next slide, please. So apart from this kind of like interesting discoveries, there are some achievements. One of them include in one weekend in 2019, citizen scientists accomplished 2,566 research hours or 3.5 months of lab equivalent research time for an Alzheimer's research project. You can see an image, a phone someone is holding, and in that you can see some kind of weird thing. It's a citizen science project. It's basically a game called Star Catchers. What it does is that it analyzes the brain activity of people who have Alzheimer's, and it sees whether there is some kind of star in their brains. Blood, it is supposed to be a continuous flow of blood, and if there is a stall in the blood flow, then it means that that person is highly likely to have Alzheimer's. So these kind of data can be used to make Alzheimer research progress. So let's move to the next slide. So what are the benefits of citizen science projects to science and society? Like citizen science enables people from all walks of life to actively learn more about the world and address issues they are curious or concerned about. So being a layman, being a common man, one can contribute to real science and help progress the science that is existing today. All the technological marvels that we see today, for example, the computer, the aeroplane, the rockets, all these came into being just over 200 years ago. I mean, after 200 years only, before 200 years, this kind of technological revolution happened. Before that, the progress was very slow. Then people started sharing their research, collaborating with others, and like it was much more easier. Now citizen science provides a much more grander scale of collaboration and participation, which can ensure that we can improve and progress science much more faster. So it broadens the scope on who can contribute to science. It enables the participants to engage in data collection, analysis, and interpretation. Anyone who can, who have basic skills of understanding something and the passion to learn more can participate in it and do something to contribute. So what it does is that it accelerates important research and discoveries and enables the participants to learn more about the nature of science and scientific reasoning. Basically, it prepares oneself for research. People who are going for research, people who are interested in science, for those people it will be helpful a lot. Citizen science is basically science, but for citizens. We'll see the next slide. So how can we get started for joining a citizen science project? Let's see. Next slide. So there are many websites. One of them is called SciStarter, from which I have taken most of the resources. And it is a globally acclaimed online citizen science hub. It's a website which has a lots of citizen science project archived and in a single place where we can go register and participate in that. Similar to this, there is one more. Let's see the next one. It's called iNaturalist. It's more related to nature and biology. And let's see the next one. And then there is Sooniverse. Sooniverse is more related to astronomy and physics. There are projects that by which you can detect new supernovas, new black holes, new radio galaxies, even new exoplanets you can detect. And there is a project called Disk Detective and Gravity Spy. Like Gravity Spy, you can what you have to do is that they will give the data from LIGO and Virgo, and you have to analyze the data and find gravitational wave anomalies. So it's basically gravitational wave research. Let's see the next slide. So all those websites you can log in, register, and choose any one of the citizen science program and do accordingly. Now let's take a closer look into some of the particular citizen science projects. Next slide, please. So this citizen science project is not limited to astronomy or biology or physics. It comprises of all the science, all the things you can put under science, even maths there are. So one of them is Great Sunflower Project. Like basically most of the biology project is kind of like we have to collect the data and submit it. Then they will use the data to analyze and find some changes in the habitat, in the appearance of species and those stuff. So then there is caterpillar counts, which measures the number of caterpillar and their seasonal variations in a particular place and like that. Then there is Globe at Night, which monitors light pollution of different areas. People from all over the world are contributing to it. By that, they are able to understand more about light pollution, how to design lights that are like making less light pollution and etc. Let's see the next one. And like from games to screensavers to more complex activities, citizen science is indeed fun. You can see downside left, there is one black color image. In that it's written city at home. That one and the bottom right one is basically a similar kind of project. It's basically screensavers. You have to register in the site. The left one is city at home and the right most down one is Einstein at home. So both of them are, it's basically like we have to install a software in our system which uses the screen time of our system. Screen time in the sense, like whenever we move out of the system turns black, right? Then there comes a screensaver, which reduces the power consumption and those stuff. So basically, these projects include putting a screensaver by the installation of a software, and this screensaver using small computation from your laptop or computer or something. I think even phone can be used for that. So using that computational resource, they will analyze the data, they will crunch the data and try to find some important discoveries. So SETI at home is currently discontinued due to lack of data, and they are trying to get more about that. And Einstein at home is currently going on, and then there is Star Catchers, which is in that green color thing, that which I have talked about, increasing the Alzheimer research project scope. Then there is Project Squirrel. It's basically going out and seeing the number of squirrels in your community and reporting on about that. Then there is a transit, like I have said, test, Planet 100 test, transit survey, and those stuff. It is similar. They will give you the light curve of a planet, of a star, and if there is a planet, it will show a dip. And if you can zoom in, you can see that there is a small concentration of dots in a line in the middle of that. That's actually symbolizing the existence of a planet or something that blocks the light from from that star. So it is possible that it might be a planet. So what we do is that we mark that area and send it back to them. Then there is some violet color with some yellow thing above, just let's do it. That one is called Gravity Spy, and it is analyzing the gravitational waves. And below that, you can see some kind of galaxy thing. That is a citizen science project. It is an Indian origin citizen science project. Basically, they will give you images of the galaxy. You have to look the manual on top of it. It will say what kind, how does a particular kind of galaxy look like. Are they spiral? Are they elliptical? Is it an edge-on galaxy? Is it interacting with other galaxy? Is it a cluster? Is it a cloud? Like that. So we have to match those images with the image provided, and we have to select accordingly. It is as simple as that. By this process, we might be able to discover a new object, or we might be able to contribute to classification of planetary, like planets and celestial bodies, which might increase further research and knowledge of our science, present day science. Let's see the next slide. So basically that's it, and the resources that I have used and the credits are like this: Sky Starters, Universe, iNaturalist, NASA, and Wikipedia. Like that comes to the end of my presentation. Next slide. If there are any questions, please ask now. If there is none, let's move it to the next presentation. Like basically, the next presentation is about asteroid search campaign, or IASC Asteroid search campaign, and I would like to call Nutan Disha to present that. Or perhaps Pavitra, can you?
Yeah, sure.
Okay, thanks.
So that's a really good presentation, and thank you, brother. It was really informative, and we also came to know that we can also participate or contribute to this. It's a really informative one and interesting. So next, I would like to call upon Nutan Disha to introduce the first citizen science project of our series and to say us about asteroids and their significance. So Nutan, please.
So, is my screen visible?
Yeah, it's visible.
Okay, thank you. Once again, a very hearty good morning to our honorable chief guest, Santosh sir, and one and all present over here. I would like to begin with a quote: Asteroid hunting is our responsibility to the rest of the planet. Now, you might have an idea of how important is asteroid hunting. So, are you all excited for this session? Come on, type yes in the chat box if you all are excited. Type yes, come on fast. So, is anyone typing?
Yeah, you got
Yeah,
quite
yes.
enough responses.
Okay, then. Okay, great. Thank you very much. Okay, so we have excited people over here. Let's start. So, firstly, contents. I'll tell you about asteroids and their significance. Uh, Asteroids and significance. So, you might know what are asteroids, and still, I'll give you some idea about it. Then, need of an asteroid search, and then about international astronomical search collaboration. Then, how to register for it, and then finally, what are the benefits of participating in asteroid search campaign? So, what are asteroids? Asteroids means star-like bodies. Aster means star, oid means shape, and these are a small rocky or metallic body that orbits the sun. Generally, these are irregular in shape and often have craters on the surface. These vary greatly in size from almost 1 kilometer to rocks of just 1 meter across. Location is main asteroid belt between Mars and Jupiter, near-Earth asteroids, trans-Neptunian asteroids, which are the asteroids beyond Neptune. Then Trojans and Greeks are also two groups of asteroids which lie beyond the main asteroid belt. And these orbit along with Jupiter around the Sun. Similarly, there are Apollo asteroids groups and many more. So this is the picture for your reference. You can see where the main asteroid belt lies, and Trojan asteroids are also present over here. So this might have given you an idea about where they actually are located. Then on the night of January 1, 1801, Sirius was the first asteroid discovered by Italian mathematician and astronomer Giuseppe Piazzi. So, but those days were really hard for this astronomer to actually discover that this is an asteroid, and he had to spend days and nights to come out with this discovery. But today, we are fortunate enough that we have modern telescopes and softwares, and it is not that hard to discover an asteroid. So coming to the point, it is the largest asteroid ever discovered, and second largest is Vesta, and third largest is Pallas, and fourth largest is Hygiea. So you can see how much wide they are. Sirius is 939 kilometers wide, and Vesta is 525 kilometers wide. Pallas is 512 kilometers wide, and Hygiea is 434 kilometers wide. Then, what is the significance of asteroids? As there are no gas stations in space yet, scientists and engineers are bound to think about how asteroids can help in refueling the stations for spacecraft. And they thought this because of the Osiris Regolith Explorer mission of the NASA. It is the third New Frontier science mission that targets the asteroid Bennu. Bennu may be loaded with molecules of carbon and water, both of which are necessary for life. And NASA said, by studying Bennu, we can better understand the kinds of objects that allowed a barren young Earth to blossom with life. Then, what's the need of asteroid search? The need is an object of 140 meters or bigger than that can decimate a medium-sized country, and so far we have found only 25% of those. And in case of earthquakes, hurricanes, or volcanic eruptions, we can't predict their occurrence accurately. But in this case, asteroid impact can be precisely predicted and prevented. And for that, we must keep on searching the near-Earth asteroids. There's the need to understand that an asteroid impact is an international issue which requires international coordination. Otherwise, there will be dangerous asteroid impacts. Actually, these impacts occur rarely. But if they will happen, the consequences will be disastrous unless we stop them, or else they will end us. Just like these trees you can see over here. These were the trees leveled by Tunguska impact. It was the asteroid impact in 1908 over Siberia. It is the region in Russia. So you can see how the disastrous impact is. Then coming on to the IASC International Astronomical Search Collaboration. So it was founded in October 2006 in Hardin Simons University. Then you can make original discoveries of main belt asteroids near-Earth objects, Trojan asteroids, centaurs, trans-Neptunian objects, comets. So by participating in this, you can even make original discoveries of these. And what's the process behind this? So IASC basically provides astronomical data in a set of 4 images. So a good quality astronomical photographs are obtained from Penn Stars Observatory by IASC. Then image sets in FITS format. FITS format is the flexible image transport system. It is a kind of file format, and it's mostly common. It is most commonly used digital file format in astronomy. So these formats are analyzed by software-trained citizen scientists, and then analysis is done on Astrometrica software by performing the data reduction and blinking of images. Then preliminary detections for the near-Earth object or asteroids is done by citizen scientists, and these detections are confirmed by IASC, and after monitoring its orbit for years, it reaches to provisional status. Finally, the discovery with provisional status receives an official numbering and can be named by citizen scientist discoverers. This campaign lasts for 24 days, and citizen scientists are supposed to analyze the 24 image sets and submit the MPC report. MPC is Minor Planet Center report. Then this is the process behind IASC program. The first, they'll take the night images of particular area of the sky and send it to Hardy-Simmons University, and then HSU, and then we takes the images and puts it in our team page, and we have to analyze those images and detect. And then for verification, it is sent to Las Cumbres Observatory, and after that, ultimately. And after that, if the verification is over, and then our discovery is termed as preliminary discovery, and after that the data is transferred to Minor Planet Center, where they do the further observations and detect the orbit. All those observations are done, and finally, if it is correct, then provisional status is given to that discovery. So talking about registration, so teams should consist of at least 2 members. So I would request you to choose your team members wisely and make sure that they will take part actively during the asteroid search. It must not happen that you are only doing and nobody is supporting you at the end. And then you need access to a Windows computer, a good internet connection, and your team should pick a campaign from the IASC website that fits into your schedule. After that, download the registration form from the website, submit it to the mail ID provided there. Then wait for a few days, and the the coordinator of IASC will send you the email declaring successful registration and will add your team to the suitable campaign. Closer to the start date, she will send you an email with instructions on how to prepare for the campaign, namely familiarizing yourself with Astrometrica software. So this is what I got after mailing the registration form. So this is the registration form. Team name, you have to type your team name in bold letters. You have to decide and type there, then country, and then team members' name. So there are total 9 rows. So at most you can choose at most 9 members you can choose, and then you have to attach it in email to the IASC coordinator. And the email ID is also given at the bottom of this form. So you might be thinking that what are the benefits and why you should participate. So it's basically you will have extreme fun in doing it, a new experience with software, and definitely you will be able to enhance your knowledge. And what else can be better than to work on best quality images from one of the world-renowned telescopes for free? It's a diamond, gold, and platinum opportunity to name your discovery and appear in the Hall of Fame of NASA IASC website. It's a golden chance to discover something new, maybe even an asteroid that might kill all of us. And if it happens, it will be a significant discovery. And ultimately, you will get the certificate from NASA and IASC. So yes, we all 4 members have participated, and trust me, it was really worth it. And we have made 6 preliminary discoveries. So if we are lucky and right enough, then we might get, and that discoveries might get converted to provisional status. And you don't have to put so much time and effort on this. You are if you are consistently doing it for 24 days of your campaign's schedule. Some of you might get worried about how will you manage your time in doing this along with the studies. So I must tell you that it hardly takes 25 minutes to analyze an image set and file an MPC report. So, okay, and so Team Cosmos welcomes you again to this beautiful workshop. So, if you have any doubts up to this part, please ask. Otherwise, we'll begin our today's training session.
So, anyone have any clarification about what she talked? You can ask now. If not, we can continue. So, Nuthan, it was really a good clarification on the topic you gave, and so I hope everyone would have taken the screenshots of the necessary slides. It was a really good clarification, also. So, next with us is the Sri Raksha to guide us about how to install the software and set it up. So, Sri Raksha, please.
Yeah, thanks, Pavitra. I will share my screen. So, good afternoon, everyone. So, till now you have seen that how we need to apply for this IASC campaign, everything. So now I will tell you about how to use it, like how to use the Astrometrica software, which we need for detecting those preliminary objects. So after you register, you will get a mail like this from the IAS. So there, if you go, you will see this thing where they will give one link and they will tell you to download these 3 files. So I will show you how to do all these things, and at the end, I will tell you guys what is the benefit of this. So you may be thinking, what is this Astrometrica? Why they are using this? So this Astrometrica is a interactive software tool for scientific grade astrometric data reduction of CCD images, focusing on measurements of the minor bodies of the solar system like asteroids, comets, and dwarf planets. So we use the version 4.10.5.437 for our discoveries. So it will depend upon your PC mode, how it will download. There are many versions in Astrometrica. It will download according to your PC. So how to set up this Astrometrica? First, you will go to this link which they have provided in that mail. Then you will reach this website where you can see the Astrometrica setup and quick start guide and practice image sets, all these things, which will be helpful for you if you do this practice image sets before starting the main hunting. So let's get started. So first, before I would suggest before downloading the software, first download these 4 files from quick start guide. It will be in the zip form. You need to unzip it. Then you can get the information from these files. So let's see from what are these files tell about. So if we see, first is a readme first file we will see. First, it will tell us about the how to set up the Astrometrica software, then how to use it. After that, we need to see the instruction for using Astrometrica, where it will tell about manual search, measuring an object, and MPC report formation. Then you will be having the false true signature one guide, and then it'll be the submitting report guide. So first I will show you guys by doing installing it myself in my PC, so that you will be getting clear information about it. So here if you see, I already came into this website. This is the main website of IASC, and here you can see these are all the scientists, citizen scientists who participated in the campaign and who got the preliminary of the detection photos, everything. So in the below thing, you will see the campaigns which will be organized and which is going to happen with date and time, everything. So you can get the information from where to which week you can guys apply. So these are the things in the main website homepage. First, we need to go to Astrometrica. There you guys see this beautiful. Already they have given one example, like one object is moving in a straight line. This is an asteroid. I think it's a detected by citizen scientists only. So there here you see this astrometrical setup, quick start guide, practice image sets. So this is the astrometrical setup. I will when you click on this. So the software is getting downloaded. After it gets downloaded, open it. So it will show some of the windows which you need to proceed to install the software. So here is the welcome sign. So it will tell you about all the things which IASC is providing you, and what are the things it will be do, what are the information it need from PC. So you need to again click on next. And at the end it will show like it is completely installed. You need to click on finish to set it up. So then when this tab will appear, so you need to press enter. After that, go to your file. In my PC, it is downloaded in a Windows C. See it whether in which when file it is get it downloaded. Here you can see that in the, and also shortcut is there provided in main window. So here also you can log in directly. This is the tab which appeared to download all the MPC database for reports, so that which will be helpful for you to form MPC reports. It will take some time. Just wait with patience. So here you can see another one tab will appear. This is the one tab which will say you have, if you have not registered into the Astrometrica software. Basically, for the, registering, they will only provide the license and key in the mail where after you registered and everything. So without registering also, you can continue this software for 100 days. So just press on continue. So here again you can see this another one tab appears, like replacing the existing files, everything. Actually you need to place yes whenever you are using it for beginning to refresh all the files which are existing. If you are already doing the image sets and you are already searching the objects And if you stopped it there thinking like I will do next afterwards or sometimes, you should press no. As I am doing it for first time, I will press S. So now it is fully Astrometrica software you are seeing now. Here you can see some of the tabs, toolbars, and icons. I will explain one by one. Yeah. So this one is a setting, and this one is the load images, and here's a stack image. Here for windows, closing all the windows and changing the form of images. And this is the, here you will see data reduction one and everything you will see. And this is a blinker. I will show you one by one. So here you can see it clearly. This is the setting. We are using settings for something if we want to change this configuration of the file. Sometimes we need to change according to the images which we are getting from the telescopes. And here it is a load images to load the images. And here the basic things which we are using in this toolbar is the settings, load images, and data reduction, and known object overlay, blink images. So data reduction is the thing where you will get the information of the sky from which the images are sent by giving the information of declination, right ascension, and the which from north part or south part. And this is a known object overlay where it will mark all the already discovered asteroids. It will be helpful for you while you are searching the moving objects. This is a blinker image. It is nothing but it will make the images to appear like slideshow or a video. It will there will be 4 images in a one set. So one image after one image it will come, which will make the object like moving. And this is the for playing the blinker and for stopping the blinker and for forwarding and backwarding the images, and this for zooming in and zooming out. And this one is the inverting the image. Like first when you download the images, it will be screen will be black, but the stars and the asteroids will be in the white color. You can change it to like you can see here this one pattern by clicking on this, where the screen will be in the white form and stars will be in the black pattern, which will be very helpful for you while discovering for hunting. So I will show you the configuration file. Yeah. And the configuration file is the main important thing while you enter the Astrometrica software. You need to see whether it is in the pc1.cfg form or in some other form, because the configuration file is the main file which will help you to identify the images. Like it is for the Pan-STAR the Pan-STAR telescope. So if it is in other form, it will be very difficult to identify those stars and objects in there. So first, here you can see it is already in the pc1.cfg form. If it is not in this form, you need to go for settings. There you can see observing site and all this information. You need to open. Here it is already in the, while you are downloading the software, all these files will be downloaded together. So here then you need to click on the psn.cfg for uploading this configuration file. Then you need to press open. So at the end it will at last it will be converted into ps1.cfg. It was usually, for me it was already existed. So sometimes it will be in the Astrometrica or some other things like you have seen here. These are some of other CFG forms like ARI24. These are for different satellites we are using this one. So then you will load the images from practice image set by clicking on this. Like it will show this one tab where you can select the file where you have downloaded the images. Then you need to click on all the things by Control A. Then you need to open. So all the images will be downloaded within a time. Then there is a data reduction point where I will download those practice image sets. It will be taking some time as it's too much long MB. So I will be showing the other things, so it will take time. So after you download everything, there is a procedure to follow to start the hunting. So this is the manual steps they have given. You need to start first. You need to start with the opening the Astrometrica. Then as I showed you, there will be one tab for overwriting the MPC report and changing the configuration file. Then load the images, and then you click on the data reduction option. Then after that you will click on the known object overlays. Then on blink images, then you will start the visual scan. And while doing the data reduction part, you may get some errors, like you can see this one error box has appeared here. So here if you see this one, it will appear like this because these errors appear due to the software could not able to match reference stars on their screens on their own. So we need to change it to automatic reference star match here, the second option. Then we need to click on OK. So most of the time this problem will be solved by clicking on the second option, and then you can start your searching. Then next will be like after you start searching and after you find one object, you will need to stop the blinker there. Then you need to see begin by forwarding and backwarding the images, and you need to name it. So for first for naming before, you need to see that whether it is an outcome 1 or an outcome 2. By clicking on that object, you will get the object verification table, and then on that there will be 3 dots like this. So you will click on that when object identification table will become like this. So there you can see that this is the one for outcome 1. The DRA, like right assertion 1 and declination, need to be equal to 0 or less than 0.2 for outcome 1. If it is less than that or 0.0, it is a known object, it is already existed after nearer to it. So then you will click on OK. Then you will see that its name will be in here and this object designation will be in here. So then you need to press on accept, or else outcome 2 will be like this, where you will find there will be more than 0.2 in this too. So that means it is not an object which is already existed. So you will click on cancel. Then you need to give the name to it. The name should be like the first 3 letters need to be come from your group name, and the next 4 designation number need to be given like this. So then you need to click on accept. This procedure need to be followed for all the 3 images, and these things you can so this is the outcome 2. After forming all this, and when you name all the objects, you will go to MPC report. Then you will find that then you will copy from there. Then you need to paste it in this website, and you need to submit it with marking the citizen scientists who have contributed for this. These things are completely briefly and explained to you by Anishruti. Then next I will show you what are the true and false signatures of an asteroid. Here if you see these are true and false signatures of asteroids. What are these true and false signatures means? These are the characteristics of an asteroid. Like you can see more moving objects in the that images. So you need to check whether it is a real an asteroid and whether it is not, because you can't name all the things as an asteroid, and you can't put it in the MPC report. And if you do that, they will again send the back, and they will tell you to again redo the MPC report and send it. So, what are these true characteristics of asteroids then? So, if you see, it should be move in a straight line and move in a constant speed, and its magnitude need to be fairly constant magnitude. And also, if you see, this is an example they have given of XS U0707. It is moving in a straight line, and also you can see that object shape is not also changing, and its intensity or brightness it's also not changing. You can This is an example for an object moving in a straight line, you can tell. And they have given examples for false images, for false signatures. Here if you see, this is the false signature of an object. Like you can see that this is not a shape of an asteroid mostly we see, and these types of asteroids are also not there. And these forms of asteroids we can't say by moving it is as it is moving in straight line, we can't say it is an asteroid, and we can't name this in MPC reports. Here you can see this is a one normal distribution graph, where this are data points where these are the signals came from those objects when you click on it. If you by seeing this graph also you can say it is not an asteroid. Like the for an asteroid, all these data points need to be nearer to this deadline, and like it need to be completely distributed. Here also you can say, but you can say that it is all data points are near to it. Why can't it be an asteroid? But if you see here, there are no data points in this region, and if you see here, it is already completely distributed all over the space. So these things are not considered as an asteroids. And sometimes you can see some of the objects moving in like this, moving in a straight line like this. But if you zoom it more, you can see that these objects are not asteroids by their shape. Like this, it will be appearing. And also sometimes you can feel that these boxes also moving, and these are also asteroids. No, it is not. It's an image, and it's an fluctuation in the image, so you should not consider all this as an asteroid. And the magnitude, this R value, main thing you need to consider is this R value. It need to be less than 1. Means you will take the R value from the 4 images, and you will differentiate between it. When you, if it is less than 1, then it is an you can consider it is an 1.2 towards an asteroid. So it may be an asteroid at that time. So here you can see it is more than 1, 19.1 and 21.0. So it is more than 1. So it is not at all considered as an asteroid. And these things should not be mentioned in MPC reports. And the saturation point of star should not be mentioned in MPC reports. And sometimes you can see that some asteroids are some asteroids, some stars or some objects near to this grid or appear to be moving, but it is not the objects which are moving, but in fact it's the grids which are moving. Like the change in position of the grids are making it look like an object. So during those time, what you can do, you can take the reference of the nearest stars. Like here you can see the one is a nearest star. Yeah, in this taking the reference of this star, you can say this one is not at all moving. And these are the points which you see where while doing the hunting should not be considered, because these are the felix and the fluctuation appear due to the moving of an images. So these things should not be considered. And you also see, you can notice these types of images, and you will be getting shocked like what are these UFOs, what are these things, spaceships. No, it is not all those things. It will be some of other image and differences you can see, but it is not an objects like this. Maybe it may be comet sometimes. These things should not be mentioned in the MPC reports. And also the after you mark the known, after you click on known orbit overlay, the that some of the asteroids which are already discovered will come like this. It will be moving. You should not mention these objects also, as it is already known. There is no need of mentioning these ones. And the bright star with different spikes like this will appear sometimes, and no need to mention all these things in the MPC report. And these are the examples of some true signature of an asteroid. Here you can see it is a little bit less brightness, so it is less brightness. So you should not consider. You should not consider it like that. You can don't think. If it is also having less brightness, and if it can be, it is moving and straight line, and all the properties of a true signature is there for it, then you should name it. And here you can see its brightness is not changing. The brightness is remaining same, but it's less bright. That's it. So you should name all those objects also. It may be considered as an asteroid, or maybe preliminary objects. It may be converted to preliminary objects also. And these are some of the asteroids with different shapes which were discovered. So at the last guide will be telling us about the submitting the report, which I have already shown you like this. And it will be telling us like we need to select the scientist, citizen scientist, and we need to copy paste the MPC report. Like how all this done will be informed you, will be explained to you by the Anishruti. So I will end my presentation. Thank you.
Thank you, Sriraksha. That was a really detailed explanation, and also you gave a live demo, and it was too nice. So finally, with us is Anishruti to show us a sample analysis using the software and to elaborate the features in detail. So Anishruti, please.
Thank you, Pavitra. So I'll be showing just a sample of how to run the image sets and how are we going to identify each object, and then how are we going to upload it in the MPC file. So one second. The screen is visible, right?
Yeah, it's visible.
Okay. So once I open the Astrometrica site, you will be first loading the images. So just click on this. Then, okay, before that, okay, these are the practice sets that Sriraksha was downloading. So once you click on this practice set, you'll get a list of sets. So each file consists of 4 image sets, and yeah, so this is one image set where you can see 4. So ending with 509.xy25.p10. So 4 images. Similarly, for each such things, each thing you will get 4 images. So for the first one, I'm going to load. What you have to do is click on one image, click extract to, and you can save it to the desktop. Okay, if you want, click on the desktop, then press OK. Or else, if you are loading too many image files, so like in case of this, you are suppose doing all this, and if you load just images, you'll get confused. So what you do, take up a folder, name it as this xy25p10 or xy26p01. In that way you can name it. Click it, then extract to that particular file. Since I just had this one, I'm just extracting it to the desktop. So I've loaded all those images now. This is 1, 2, 3, 4. These 4 images respectively. So then close this, open Astrometrica file, Click on load images. Since I've saved it on the desktop, these are the 4 images. So this is 509, the first image, open, and yes, it's loaded. Then the second image, 528, yes, open. Then the third image, then the fourth image. Okay. So, what exactly by inverting the image means? Now the screen is black and all the stars are white. In case if you're not able to distinguish how the stars are moving, or if you prefer the stars to be in black and the screen to be in white, just click on this. Everything gets changed. Okay. So next step is data reduction. You will data reduct and so sometimes what happens is when you give manual reference star match, it doesn't work. So just give automatic reference and press OK. Then it's done. Close this. The next step is data reduction is done. Then go to node objects program. So what this does this sometimes some objects are identified, some objects are unidentified. So when Shreeksha was explaining the previous part, there are some objects that were marked as red circles with some certain names. That's what this known objects do. Then the next step is to blink the images. So basically when you blink the images, so what happens is the image continuously runs. So 1, 2, 3, 4. The all 4 images are continuously simultaneously running. So it appears as if it is a video. So then this is done. Now what you have to do is you have to check it grid wise, each object, if it is moving or it is not moving. So because it is so small you can't see, we just zoom it by zooming it. So a bit more. So once you are done with this, the image is moving. Okay. So this is continuously moving. In case you feel that you want to stop at certain image, just press on this and the image will stop. It is on image show. Then if you want to move to the just the next slide, you don't want to play it, you just want to move the slide to the next, just press this. And if you want to go to the previous image, just press this. Okay. After that, this is the play button and it will again start doing its own process. So basically, it keeps on running until you stop. So this is the first bit. So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are a total of 16. And analyzing each set hardly takes around 1 or 2 minutes. So each grid takes about 1 or 2 minutes. You can easily complete a whole image set by 15 to 20 minutes at the maximum. So I'll zoom it and check for the first grid. So we'll check the first grid. So let's see if this is moving. Okay, this is not moving. See the image, all the 4 images, the object is on the same position, right? So this cannot be accepted as a moving object. Next. Can you see anything that is moving? No. So once like you can zoom it more if you want, or else let's invert. So in even if you think that that one is not working, you can go on with this and just try it. See, this is not moving even though the images are moving. This is not moving. This is not moving. So yeah. So what we'll do? We'll move on to the next grid. Okay. I'm just lowering this. We'll go it vertically. Okay. So now this isn't moving. This isn't moving. This isn't moving. But see this. Can you see? Let me just pause it. Okay. Let's come to the first image. It is at this point. The next image, it is at this point. The next here, the next here. The first criteria for you to identify if that is an asteroid the main thing is you should check if it is moving in a straight line. It should not go in a zigzag manner or a curved manner. So now I'll just play. See, this is going in a straight line. You just can keep a scale and just keep and see if it is moving in a straight line. Okay. So what I'll do, pause the image, go to the image one, click on the image, and here it comes. See the points. Okay. So so uh, since I can't see where the DRA or BDE is, so I'll just close it. Name according to your preference, like the first three letters of your team name and followed by the image. So this is my first object, right? So since our group was Cosmos, so let us say COS followed by 0001. Okay, 4-digit number. So this is the first object. So 0001 and press on accept. Okay. Next, go to the second image. Click on the okay. Sorry. I forgot one thing. Let us see the magnitude. So magnitude is this R value. So R value in the first is 21.2. So image 2, click on it. Name it as cos 0001 since it's the same object. It is R value is 21.3. And please, if you can't see the image properly or if you're facing any issue or you have any doubt, feel free to interrupt me in the between and ask it. That would be better. Okay, pause. Okay. Then the next image 3. Okay. So this is R value is 20.9. And let's name it as cos 0001. And the next it is here. R value is 20.5 and we'll name it as cos 0001. So out of the four magnitudes, the least was 20.5 and the highest was 21.3. Okay. So what you'll do is basically subtract the highest minus the lowest value. So you get around 0.8. So 0.8 is less than 1. So that means what we have done is so far right. So this is our first image. Now MPC report. Check the MPC report is filled. This is the magnitude 20.5, 20.9, 21.3 and 21.2. So this is the first image. And similarly, you are going to analyze the next image if possible. In the same grid, it may be available or it may not be available. So just run it. Let's see. See. Now if you see, you can see that moving in a straight line, right? Is there anything else that is moving? If anyone can see that, just tell me. I did find out something. Did anyone else find out it is in the same grid?
In the bottom
Yeah,
right
right.
corner.
Yes, right. So we'll just stop it. Image 1, I guess. Okay. This was the one moving. Am I right? You want me to check? See. Now it is here. Next point, it is here. The next point, it is here. The next point, it is here. It's moving in a straight line. So let's come back to the first image. Click on the image. Let's name cos 2. Cos 0002. Okay. Next, go to the next image. Click. Oh, sorry. I forgot to check the magnitude of this. 19.8, right? So, fine. Next is here cos 0002. X. Then the next image. Cos 0002. And then again the this here, S cross 0002. Okay, so let us run this again, check if it is correct. So 2 images in a single grid. Similarly, you can find for the other grid. So just stop it, go to the NPC. This is how you do it. I made one small error, that is, while naming it for the first image, I by mistakenly named it as 0001. In case that is the case, your whole procedure is gone. You have to restart it again. Or else, once you have done this, go to the NPC report, copy the whole thing. Okay, just copy it down. Then go to this site where your group will be visible. Okay, so when you go to your group ID, so basically when you go to your group, they'll show this image set. Okay, so when Sri Raksha was presenting, you saw a box and there were certain details typed, right? It will be totally blank. Just paste it there. Select your image set. Okay, so before that box, there is another box where you will set which image set. So right now the image set that we used was XY25P10. So that name will be given and you will select XY25P10, copy paste this image set, submit it.
Are you presenting?
No, I'm not presenting because
Okay.
The campaign is over. We can't go to our group right now. So if you form a group, you will get that set and how to submit. There is a box. Just Sri Raksha, can you present that PPT of yours where you're showing the difference?
Yeah, I should. I will present.
Yeah, you can go to that. So basically, this is the image. So above this, you will have a like a tabular column of all the list of images, all the image sets. So XY25P10, XY25P01, XY25P11. So there are different ranges. Then you will select. Before this, there is an option where you have to select which image set where you select. So what I'll do, go to that, click it, say that it is XY25P10 done. Then there is an option citizen scientist. Okay, so who all found out it, basically all the members of your group, just put a tick on it. Now an image set which I copied in Astrometrica file, did you see that? Just paste it and submit report. Boom, done. That's it. And you have submitted a report of one folder. Clear? Any doubts? You want me to again show the image set or anything that? Okay, Sri Raksha, thank you so much for that. It's enough. So anything you want to see another grid or something. Okay, suppose if you're not getting any image set. Okay, let's say if you're not getting an image set. So what happens is, you can see my screen, right?
Yeah.
So suppose in the first grid, we couldn't find anything. Suppose think all the 16 grids, you didn't find even one single object. What you're going to do is, once you do this known objects overlay, don't blink. Okay, you can close this. And okay, then what you do is click on any one of them. It will show this way. Okay. Then just you'll get some information, press accept, and that will come in your MPC report. Since I have uploaded this is something else. If suppose nothing is there, click on one known object, its MPC report will be here. Instead of this cos 001, its MPC report will be here. Just copy it, copy the whole, paste it on your MPC report. This particular thing, okay, this particular thing you can delete over that site. Just delete it and write it no objects found. And that means you have not found any objects in that particular image set. Clear? So we have studied two cases where you can't find any images, sorry, any objects, or in case if you find objects, what are the procedures? Any doubt? Do you want me to run any other image set or see, or if this is clear? Any questions?
Yes, it is a thank you, Shruti. That is indeed a very good demonstration and a good explanation you give, and interesting session too. Now, I would like to ask Santosh sir to say his view about the workshop. Sir, please.
Thank you, Pavitra. I'm audible?
Yes, sir.
Yes,
You
sir.
So first of all, I want to congratulate Vaishnav, Nutan, Srexa, and Annie for their participation in observing the near objects to the Earth, and by using the fan images, by analyzing them. And they have mighty a very good experience in this field, and they have shared their personal experiences by providing the idea of what is the citizen science and basic aspects of astronomy, and then they have given a presentation of Astrometrica, and then they have given the demo also. So it is really fascinating, and definitely I hope other participants have also get benefited with this. I understand these are the constants are there online, because these are the some of the tools where we required online hands-on experiences. So because maybe in one day it is not sufficient time for all of us to understand everything, because when we are actually going to work out in the system, then only we can understand what are the uh, things we are or problem we are facing. So first of all, I thanks all the RI Cosmos Club for providing this wonderful opportunity for us. And further, I request because soon you are going to come into the RI campus, and in the future, maybe I hope this pandemic situation may minimize. So, if it is possible, then have in weekend days, such type of hands-on experience where all the community of those who are interested in this field they have joined, and RI have all the facilities of computer where they can utilize or they can use their personal computer, and let have a hands-on session for that, because when actually we are going to do hands-on, then only we realize how things are going to happen. So that is a really wonderful session all people have taken up, and I will congratulate. And part of that, those participants, they are listening very essentially, and want to learn these things. That is also I thank them that definitely they have also benefited with this session. Thank you all of thank you Cosmos Club.
Thank you, sir. Thank you so much, sir. This means a lot to us. And here we came to the end of the workshop. And if anyone have anything to share about the workshop, anything, you can freely do so now.
Okay, so guys, when we were applying for this, we were very new to it. We didn't have any idea what we are going to do it. No one were there to guide us. So it was like everything, learn new, learn new. So these demonstrations were not done. We ourselves had to do all the experimentation and do it. So it took lot of time just to understand what the whole thing was. And we have just explained you basically what you are going to do, which has reduced your work by half. Okay, you don't have anything much to do. So I think the very first image set when you will be doing, you might think that okay, this might take a lot of time and it is just waste of time or something. Some thoughts will go, but once you start doing one or two image sets, then it's like you get addicted of doing. You just sit on the computer, just randomly. You have a free time, you just pick up and do it. And once you're done, if you're lucky enough that obviously you'll get selected for the preliminary sets, and if that happens you should be very grateful because you're getting a certificate from NASA itself, and it's like one of our dreams come true. So I request you all at least to try it so that you can really get the essence of what it is, what we have got.
Yeah, Shruti, that's true. And if anyone wants to participate, you can register in the link in the chat, actually. And anyone else wants to share anything? Yeah, welcome. So here we came to the end. Yeah, thank you, Deepalia. It's a really informative session. So thank you everyone for participating, the students from RIE, outside RIE, and Santosh sir, thank you sir for participating and being with us. And I hope the session would have been a meaningful and fruitful one. And we all have learned something new today. I hope we all have learned something new today. And I would like to conclude today's session with a quote. So if you learn something new every day, you can teach something new every day, by Martha Stewart. So thank you once again. Have a good day, everyone.
Okay, so if anyone wants to register, just press the link or you can contact any one of us. We'll guide you all through that. Okay, see you in the next session. Bye bye.